Here's a fact that genuinely surprises almost everyone the first time they hear it stated plainly, because it contradicts an assumption so deeply baked into how most people picture human history that it barely feels like an assumption at all. Very fair, pale skin, the kind associated today with large populations across Northern Europe specifically, is not an ancient trait. It's not something that's been quietly sitting in the European gene pool since humans first arrived there tens of thousands of years ago. By the honest evidence coming out of ancient DNA research over roughly the past 15 years, widespread very fair skin appears to have become common in that specific region only within the last 6 to 8,000 years, a genuinely tiny sliver of time compared to the tens of thousands of years humans had already been living in Europe before that point. For an enormous stretch of European prehistory, the people living there almost certainly did not look the way most people instinctively picture ancient Europeans looking at all. This isn't speculation built on guesswork. It comes from a genuinely remarkable piece of ancient DNA detective work, and understanding it requires going back to something we've covered on this channel before, because this entire story is really the second half of a tale that started when our ancestors first lost their fur. Quick recap, because it matters directly for what follows. When early humans lost their body hair somewhere around 2 million years ago, largely to solve an overheating problem created by our rapidly expanding, metabolically expensive brains, the bare skin left behind needed protection from direct ultraviolet radiation, and the earliest humans, all living in equatorial East Africa, almost certainly evolved deeply pigmented, melanin-rich skin to provide exactly that protection. Melanin does two critical jobs simultaneously in this context. It blocks UV radiation from damaging skin cells and causing cancer over a lifetime, and it protects a nutrient sitting just beneath the skin's surface called folate, which gets broken down and destroyed by UV exposure, and whose depletion causes serious birth defects and reproductive complications. In the intense equatorial sun our species evolved under, dark skin wasn't a neutral cosmetic trait. It was essential survival infrastructure. Here's where the actual makeover part of this story begins, because that same protective trait, so essential near the equator, becomes a genuine liability the moment humans start moving toward regions with dramatically weaker, less consistent sunlight. And this is where the second nutrient in this story enters the picture. Vitamin D. Human skin doesn't just react to sunlight. It manufactures an essential nutrient directly from ultraviolet exposure, synthesizing vitamin D through a photochemical reaction happening right in the skin itself, a nutrient critical for calcium absorption, bone development, and immune function, and one that's genuinely difficult to obtain in sufficient quantities from most available food sources alone, particularly in the specific historical diets available to populations living at higher latitudes. Melanin, by design, blocks a meaningful percentage of the UV radiation reaching the skin. Near the equator, where sunlight is intense and abundant year-round, this trade-off works out fine. There's more than enough UV penetrating even heavily pigmented skin to synthesize adequate vitamin D. But as human populations pushed further from the equator, into regions with weaker sunlight, shorter days, and long, genuinely sunless winters, that same protective melanin started blocking too much of an increasingly scarce resource, creating a genuine, biologically serious vitamin D deficiency risk, one connected to rickets, weakened bones, and broader immune complications capable of measurably reducing survival and reproductive success over generations. So evolution, facing this exact trade-off, essentially ran the same calculation that had originally produced dark skin near the equator, except pointed in the opposite direction. In low UV environments, natural selection increasingly favored lighter skin, capable of allowing considerably more ultraviolet radiation through to sustain adequate vitamin D synthesis, even though that same lighter skin offered less protection against the folate-destroying and cancer-causing effects of UV exposure. A trade-off that made evolutionary sense specifically because the actual UV exposure in these regions was already so much lower to begin with that the original protective benefit of dark skin mattered considerably less than the vitamin D benefit of lighter skin. Here's where the genuinely stunning part of the story arrives, because for a long time, researchers simply assumed this shift toward lighter skin in populations migrating out of Africa happened relatively quickly after those populations arrived in lower UV regions, tens of thousands of years ago, roughly in step with the broader out-of-Africa migration timeline we've discussed previously on this channel. Ancient DNA research over the past decade and a half has overturned that assumption in a genuinely dramatic way. And one of the clearest, most widely reported pieces of evidence for this came from a 9,000-year-old skeleton discovered in Cheddar Gorge in England, nicknamed Cheddar Man, whose genome was fully sequenced by researchers at the Natural History Museum in London and University College London in a widely publicized study released in 2018. Cheddar Man's DNA showed the genetic markers associated with dark skin pigmentation alongside blue eyes, a combination that genuinely surprised much of the public when the reconstruction was released, because it directly contradicted the common assumption that ancient inhabitants of Britain, living there for thousands of years already, would have already developed the pale skin associated with the region today. Cheddar Man lived roughly 10,000 years ago. His ancestors had already been living in what's now Britain or in nearby parts of Europe for a very long time before that. And by this genetic evidence, he still had skin considerably darker than what's typically associated with the region in the modern population. This single skeleton wasn't an isolated fluke either, and that's the piece that turns this from a single surprising data point into a genuinely robust scientific finding. Broader ancient DNA surveys, examining genetic markers across numerous prehistoric European skeletons spanning a wide range of dates and locations, conducted by research teams including work published by geneticist Iosif Lazaridis and colleagues, have found that the specific gene variants responsible for very light skin in modern European populations, particularly variants in genes called SLC24A5 and SLC45A2, appear to have spread and become common considerably later than previously assumed, with meaningful evidence suggesting these variants only reached high frequency across much of the European population sometime within roughly the last 6,000 to 8,000 years, a time frame that lines up closely and, in a genuinely striking way, with the spread of agriculture across Europe during the Neolithic period. That timing connection is worth sitting with directly, because it suggests something considerably more specific than humans in Europe just gradually got paler as more generations passed. Researchers have proposed a genuinely compelling dietary explanation tied directly to this agricultural timing. Pre-agricultural hunter-gatherer populations across Europe likely obtained meaningful dietary vitamin D directly from food sources, particularly fatty fish and animal liver, both of which naturally contain relatively high concentrations of the nutrient, providing a dietary buffer against the reduced UV synthesis that darker skin would have otherwise created in a low-sunlight environment. Once populations across Europe transitioned toward agricultural diets during the Neolithic period, increasingly centered on grain crops that contain little to no naturally occurring vitamin D, that dietary buffer largely disappeared, and the evolutionary pressure toward lighter, more UV-permeable skin, capable of compensating through increased sunlight-driven synthesis, instead, suddenly intensified considerably. Under this explanation, the shift toward pale skin wasn't simply a slow, inevitable drift that happened automatically once humans arrived in a low-sun environment. It was accelerated dramatically, and specifically, by a change in diet that removed an existing nutritional workaround, forcing biology to compensate for a gap agriculture itself had created. Think about what this actually means for how you should picture the deep history of a place like ancient Britain or Scandinavia or numerous other regions of Europe now strongly associated with pale skin as an ancient, seemingly permanent regional characteristic. For the majority of the time humans have actually lived in these specific regions, the population likely looked considerably different and considerably more darkly pigmented than the population living there today, right up until a genuinely recent evolutionary event, recent enough to fall well within the time frame of written history in some parts of the world, recent enough to overlap directly with the invention of agriculture, the construction of Stonehenge, and other developments most people already mentally categorize as historical rather than deep prehistoric. There's a broader lesson embedded in this story worth spending real time on as we close out, because it cuts against an assumption that shows up constantly, often without anyone consciously examining it, in how people casually think about race, regional identity, and deep human history. The specific skin tones associated today with specific regions of the world are not ancient, fixed, unchanging markers stretching back to time immemorial the way casual intuition often assumes. They are, by the actual genetic and archaeological evidence, considerably more recent, considerably more responsive to specific environmental and dietary pressures, and considerably more changeable across evolutionary time than most people's mental picture of human history typically allows for. The population of ancient Britain looked different from the population of modern Britain, not because of some ancient, unchanging essence tied permanently to that specific patch of land, but because human biology has spent the entirety of our species' existence doing exactly what it's always done, quietly, constantly recalculating the same brutal trade-off between blocking dangerous radiation and synthesizing an essential nutrient, adjusting the visible result every single time the underlying environmental and dietary conditions shifted enough to demand it. The face looking back at you in the mirror right now, whatever its specific tone happens to be, is not a fixed, ancient inheritance handed down unchanged since the dawn of your particular corner of the world. It's the current, temporary answer to a calculation your ancestors' bodies have been quietly running and rerunning for the entirety of human history, and there is no reason whatsoever to expect that calculation has finished running yet.